So I'm starting the recording now, but we had a question about what this means, and we'll probably talk about it a little bit more today too, because this is actually a pointer. But I guess the thing to imagine is, let's say I have some sort of rocket class, or I guess I'm saying rocket because of the last assignment. I was just grading this, so I'm thinking about it. So that had, stuff like a float for acceleration, and it had maybe an int for seats, like the maximum amount of seats that it can hold, and it had getters and setters, and after, let's just say with the implementation I did, it had something called like bool check availability, and I think it returned an int by default. I just changed it. So in your main function, you ended up in that last assignment making a rocket called obj1 and a rocket called obj2 and 3 and 4. But let's just say, just to give them a little bit more specific names, I make an instance of a rocket. So I create a rocket with the line rocket R1, and then I do another one with rocket R2. Okay, so we'll say the red one on top, that's rocket R1, and this one right here is R2. So now, these specific rockets, this R1 and this R2, those are instances of a class, right? They're their own living objects. And another example of that might be if I had a person class. An instance of a person might be me or you or anybody else. You're your own individual. You have your own name and stats and age and stuff like that, right? So same thing with these rockets here. I have this unique rocket 1. It's its own instance. It's whereas this is maybe a description of a rocket, or like a blueprint. These are instances. They are like actual living, breathing, real things that match that description, right? So for instance, this one might have an acceleration of 12.1 and 14 seats, and then its check availability does some certain things. So maybe it returns true sometime. So this one, I guess, is a little bit less so than the other ones because it's a function call, so it might change. And then this one maybe has an acceleration of 18.6 and 10 seats, and it returns false. So they each have their own living, breathing things that are based off of this description, right? So when we go to use this keyword, so consider if I was to call check availability. So if I did r1.check availability, let's say check A, then there's something I need to consider, which is that this check availability is getting called on rocket 1, or by rocket 1 rather. This check availability specifically belongs to rocket 1. So when I go into any function that I'm calling with an instance of a class, in this case, this unique object here, right? Rocket 1 is its own unique thing. I can talk about the thing that's calling it using this keyword. So if for some reason I wanted to set the seats here, so let me just scroll over to the side. Or let's say check availability, bool check availability, check avail. Let's say we want that to return whether the amount of seats left is available, if there are any seats available, which would mean that there's like the total number of seats minus the booked number of seats is greater than 0. So I could say something like booked minus seats is greater than 0. Now I don't need this keyword here, but what I am totally allowed to do is if I wanted to specify, well, I'm talking about the booked seats of this rocket, the rocket that's calling this, and not any other rocket. So whereas Rocket 1 was the one we said was calling it. R2 also still has its own seats and books and stuff like that. I would say something like this, booked, minus this, and then there's the arrow, which is a new operator we haven't gone over. It's really the same as the dot, it just is for pointers instead of objects. Is greater than 0. So I use it to talk about the specific instance that's calling it. And since Rocket 1 is the one that called it here, this in this case is talking about R1. That's what this is. It might make a little bit more sense when we get a little bit more into pointers, but that's generally what it is. You don't typically need it a whole lot. It's just it's there if you have ambiguity. So I'll pull up an example in a second, but has that answered your question so far? Hopefully. If it hasn't, totally stop me. Yeah, okay, fair enough. I'll pull up an example of when you would actually use it. It won't really be super necessary all the time. We have most of the class here. I guess about as good as we're going to get. Oh, I did get an email, but it's not from a student. Okay, that's all right. Okay. Yeah, so I actually wanted to revisit this game program for a few seconds because there were some things that I didn't go over, that I maybe just glossed over or didn't define well, that I wanted to go over for the sake of assignment 3. And I can pull open this as an example because I have it somewhere, I think. Oh, there it is. There's one, and there's another. This might be a better example of it. This is actually a fairly practical example. So you'll notice here in this constructor I had, so I had a player constructor for the player class. I called it with an argument position called position, and that was the same name, right? This position here, which is the parameter to the constructor, was the same as the position, the name that I'm using right here, which was the position name from GameObject, which it inherited. So the player has a position class, which was just an XY coordinate called position with lowercase, and then I also had a parameter with that same name. I think I did the same thing here too. So something to note about that is that if I just use it, I think we discussed this a little bit before, but if I just use this without this keyword, then when I say position, it's referring to this one, not the one that belongs to the player. And the reason is, it's like when you do a global, like if I wrote int x in a global scope and then had a function with int x, then the global one gets overwritten by the local one to the function. Same thing here. When I say position here as a local parameter to this function, it is going to overwrite the one that is in the scope of the class. In this case, the base class that we inherited from. So the way I specify in that case that I'm talking about the one that belongs to the position and not the parameter is using the this keyword. That way it knows, this is the position that belongs to this instance, not the function. So that's one practical use of it. That's what I usually use it for. And then there is also, I modified this off out of class. So I kept a pointer to the player, and we'll get into more pointer stuff today. But I keep a static pointer to the player, and this is just common practice to do. I left a big comment about it in game development and general programming where you're going to use a specific instance over and over again. So for instance, I programmed mobile apps over the summer, and I would keep pointers. So I had a class called user that kept user information like email, phone number, that kind of stuff. I kept a static link to the user throughout the entire program. That way I could access the user no matter where I was because I need it constantly. So if you're going to use something a lot, it's a good idea to keep a static either pointer or reference if you're doing a different language. And in this case, I set it right here in the player constructor. The player gets set to this. That way I always have it. And so you'll see that I can specify that I'm talking about this specific object by using the this keyword. So it knows here when it's setting the player, I'm talking about the object that's calling it. So hopefully that answers that. And we'll talk about this a little bit more too, because it is a pointer, and that's where the arrow operator comes into play. And we're going to be talking about pointers for probably the next 2 weeks, if anything. Okay, so the other things I wanted to talk about, pretty minor. So the assignment uses the word override, but I don't ever think I explicitly said what that means. An override is just when you, for lack of a better word, override a function, basically replace it. So for instance, I have this void update here in GameObject. So GameObject has an update, and what it does is it moves the position down by 1, which was just gravity. And then it checks if you're under the floor, it moves you into the floor, and then it adds the object to the screen. Now, if I wanted to, I could change this behavior or add on top of it, by creating an update function in the inherited versions. So I could go down here and say, I want player to have an update, and if you're overriding it, it needs to have the same exact arguments. So I would need it to take the screen. And then I could rewrite it. And so if I run the game now, what should happen is the player will just do nothing. Whenever it starts running. And the reason is that I've written this update here, and it's going to override the base class version of it, and it's just not going to do the base class version anymore. So if I hit right here, the player is still getting that called on them. That's strange. Because I didn't write a body? Or perhaps it's because I have it as a game object type. That's a strange side effect in C++, if that's the case. Let me try one thing here, just to see if it works. So let's try, instead of doing this, I had a list of game objects that I was calling. Let's try doing player.update. Screen. Oops. Right. Yeah, so you see it does nothing now. That's a strange feature of C++. I didn't know it did that, actually. So I guess if you have it as a generic type, if we do that whole thing we talked about last time, where we keep the type that's above it in that inheritance, like tree kind of structure, then I guess it calls that version of it, even if it knows it's not that, which is not what other languages do, so that's why it's a little strange to me. They normally will just call upon whatever the object actually is, that one. But hopefully that at least gets across the point of what an override is. And I could fix that by simply casting this to a player, but I'd have to know where the player is. So yeah, the idea is that it overwrites that thing. So the reason it was printing nothing to the screen there was because I was calling the player version of the update, which is completely overshadowing the one in the base class. So when I give a different name, it will destroy it. Or not destroy it, but it will take precedence over it. And so if I wanted to make it call the base class one, I would specify here that I want GameObject.update. And so that will now call, and I need to parameter. So now if I did that, it would call the GameObject version of it inside this. So this can be useful because I can then override it, call the base class version of it, and then write my own code, basically just modify it. So that is a option that we can do. Two other things. He said the word inline in the assignment 3, I noticed. Oh yeah, basically ignores the base class function, does what is in the inherited. Yep, exactly. So we'll ignore it, but it does still exist, and you do still have the ability to use it. You just have to specify which version you want specifically. So if I say game object scope resolution operator here, it will know to do that one. So if I actually went back really quick and kept this where it was just the player updating, you'll see it should work again. Because now it knows I want to call the game object version of it. What is a practical use of this? So if a game would definitely use this, but if you want something to have a different behavior than its parent. So like an example of that I did over the summer, again, I was programming an application, is I wanted pages, so each page that you open in the app was its own class. What I wanted to do, so I had one big class that they all inherited from that just had general information. And so what they did by default was they would refresh on a timer, like, every 3 minutes or something. But if a page didn't need to access the internet, I don't really want it to do that, right? Because, refreshing and checking the server doesn't really do much if, there's no reason to check the server. So what I would do there is I would override the constructor, or there was a function called, I guess a method called on appearing, and there was also another one that I created that would go off on a timer, and so I would override the timer method or function to not refresh it. So simply by redeclaring it, it stopped refreshing to the server. So if you want your inherited class to have different behavior, or if you want to add on to their behavior. So I've written games before where I can do that. So I have a game object class that applies physics every single frame. So it makes you go downwards, and it checks for collision and does that stuff. But if I was to write a player, then I need to have more stuff every single frame. So I would add on to the update function by overriding it, and then simply adding controls to it, and stuff that handles other things like what state the player's in, running or jumping or something like that. So there's a lot of practical applications to it. It's just a matter of what you're trying to do. Right, so the other thing was use the word inline, which really isn't that difficult. I don't think I ever explicitly said it. So an example of an inline function, which I'm sure most of you wrote anyways, would be something like this. Inline just means that we write it on one line right next to the function declaration. Maybe not even one line, but inline means that it's within the class declaration, I suppose. And we usually just write it on one line like this. So that's an inline function, which he says in the assignment. So I just wanted to make sure everybody was clear on that. Yeah, inline. One word, I guess, no dash. And then the last thing that was in the assignment that I seem to have glossed over was, and I think the reason I didn't do this is I didn't think it was a thing in C++. I knew it was in other languages, but I thought I remembered Googling it, and it just didn't work. But apparently I'm wrong. So it's a little bit different than it is in like C# or Java, but it's still pretty okay here. So I have the ability to call a constructor of a inherited class from my derived class, and that's just useful for saving time. So if I wanted this player here to also do the same thing that's done in the game object, so yeah, actually this one might be good. Let me override this. So I have this game object constructor, and it sets the position, it sets the character to the past character here, and then it generates an ID. So maybe I didn't want to write all these 4 lines of code. So what I can do is I can call the game object constructor with the position and with the character P. Now I don't need this at all. And it will generate the ID up there too. So this is almost also like an override. In fact, this is really just an override, but for constructors. So this will call the game object constructor first with these parameters, and then it will come back to this one. So let's just take a look at that really quick in the debugger. So if I go up to the player here, and then I run the debugger, you'll see if I step forward, it goes to the player constructor, and it should, yeah, go up here, and it will say, you want me to use the game object constructor. So it will go and use the game object constructor first, using the position that we gave it. So it will have access to any parameters that you gave in the actual constructor here itself. So this position and this position are the same one. So it's saying, I want to call the game object constructor with the position I was given and the letter P for the character. So you'll see here it goes up, it constructs a position, it sets the position, sets the character, which we can see is P. It's a little bit small, but it is getting the P that I gave it. And then it generates the ID like we had before. And then I can add the extra behavior that I wanted on top of this. So I wanted the player constructor to just set a reference to itself so that it can be accessed later for convenience. And so it does that. So the thing to really note about that, I think, and you'll see it should work fine again, is that when I do a constructor override like that, that it always calls this constructor first before it executes the body is a very important thing to note. Because if you don't have all of these references set up here, then you might get some sort of error in your body if you think that this will execute before that does. So just something to consider. So he mentions that, and you should be using it for the red, green, and blue classes in the assignment 3. So you want the red class to use the player class base constructor and then have it call it like that. So give it a name like red class and character R. I don't remember exactly what the parameters were, but that's the general idea. Any questions on any of that stuff? Just some things I overlooked as far as object-oriented programming that you need. We got time today. Could you go over assignment 3 a little bit? Yeah, I'll probably do that at the end. I'll talk about it a little bit more. I've spent a little bit more time looking at it since the weekend. Okay. So if nobody has questions on this specific object stuff, let's start talking about pointers again, I guess. So let's do a little bit of a review, and then we'll start talking about how we can use pointers and why we even bother using them. So pointers are a thing that's exclusive to C++ and C, so it might seem a little bit strange if you've done Java or C# before as to why we're even using them, but they are in those languages. You just don't really have to think about it, which may or may not be a good thing, depending on how you look at it. So let's just create a new project. Move that off to the side for a second. Okay. We'll come back and program in a second. Let's just talk about what a pointer is again, just as a refresher, and then how we can use them. So last time we started a little bit talking about pointers, and so we talked about the idea that we have memory. And again, I mean RAM when I say that, on a standard computer. And so memory is just a series of blocks of data, typically a byte. And when we go and create data in an actual program, like an integer, a boolean, or a float, it has to put it somewhere into memory, or instructions themselves, even stuff like add or subtract or divide. All of those things need to be loaded into memory in some way, and that's going to be done as binary. And so we need to consider a few things when we do that, which was, again, the size of the data that we're dealing with and the location of it. And so we're going to deal more with the location, if anything. I'll just not draw another one. So this should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we started counting at 0. Okay. So we had the idea that these were addresses. So they describe where in memory something is. So for instance, this is block 0, this is block 1, this is block 2, 3, etc. And then the actual determining of the size thing has to do with the data type that we're using, which the compiler will determine for us. So consider I'm going to make a integer pointer. And remember, the way we do pointers is with a star. It's not high up like that. It's, right next to it. But I'm going to go int pointer here, and then I would say something like integer x. And so recall that what the system will do is it will, when it sees this line, and actually with this line as well, but we'll ignore it, it says, I need to make an integer x and put it somewhere in memory. So yeah, actually let's explain this a little bit without me. I was going to put like equals 3 or something, but consider that this is just all binary and you have no idea what it's going to be because it might have been used by some other program, and an efficient way to deal with memory is to just not delete it at all. So there's a common misconception that maybe when I delete memory or stop running a program, all of that memory gets turned to zeros, but that's not really what happens. It just stays as it was and it loses access to using it. And the reason is just, it takes a long time to set something to 0. At least comparatively, it takes time. So this could be all just random garbage. So when I say int x, and this is why you should always initialize your variables, it will say, I'm going to go make an integer x. And so it will, let's just keep a little box up here. So let's just make one that says variable, and then the address, and then the value. So I created a integer called pointer. The address, let's just say, is here. So we'll say pointer goes to 6, and its value, we have no idea. Now we're going to create a variable called x, and let's just say we allocate it to 3. So x is in here. Yep, that's right. 3x. Now consider that when I do that, all this line says is make an integer x. It doesn't tell me what x is equal to. So what's in x is random garbage. We have no idea. This is why if you don't initialize your variable and you don't have a compiler that initializes things for you, you might start it up and you'll see that x prints out as negative 32 billion or something crazy like that. It's just reading the random binary that's left over there and just saying, that's x. So that's the problem with that. So that's what this would do so far. Does that make sense to everyone so far? So whenever I create a variable, it finds space for it, and then now the data there gets interpreted that way. So maybe next in my program, I would do something like int x equals, oh, whoops, well, I already said int x, so that's not valid. I might say something like x equals 6. Now what this will do is it will go to that location, and it will say, I'm going to make that stuff 6. So now the value there is 6. And so whenever I access it, that's fine. So what the system does is it keeps a pointer itself to your variable and sets things equal to that when it does it, or when it does any sort of assignment. Okay, so really quick, what would happen if I wrote this line of code? What would get printed so far? And this is just review, so if you don't remember, no big deal. But does anybody remember what this would print? Or what the ampersand means?
The address.
Yeah, you got it. Address, right? So, yeah, so this would print the address of x, which is 3. Yeah, good job. So, if we use ampersand, it will give us the address of the thing. So let's erase that really quick. Now, if I wanted to keep track of that address, I could do something like this. So a pointer keeps track of an address. So now when I do that, my value of the pointer becomes 3. And this might seem a little bit confusing at first. Don't worry too much about the fact that I'm storing the pointer. But the pointer itself is going to get the address of x. So pointer gets address of x. Right, so then last thing we'll do for a refresh here is just say something like, so what would this print now? Cout star pointer. So, whereas this one gets the address, yeah, 6. Oh wow, I put these in really bad locations, huh? Let me change something up here. This is probably a little confusing. Let's change this to a 7. The value of x, that is. So the value of x is 7. I think that was kind of bad of me. So we'll print 6. And 7. Yeah. Oh wait, or maybe you did mean that. I'm sorry. You might have been right. I had an ambiguity there. It would print 6. I'm just not thinking. Yeah. Sorry, you were right originally. My bad. I tricked you. By simply changing the number. I cheated. Okay. But yeah, I think you were right there. So what this does, right, is it says I want to get the contents at the address described by this pointer. So this pointer, the address doesn't really end up mattering. We'll get the value at address 3. So it will go and look at address 3 and it will say, oh, there's a 7 there, and it will print it. So this would print 7. Everybody okay with that review? So a pointer points to a thing. So a pointer can only store an address. Yep, that's exactly what it does. What if you say pointer equals x? That will give you it should give you a compiler error without an ampersand. I hope it gives you a compiler error. Let's find out. It might not. Actually, I know for a fact it should. It should. Int x. Int pointer equals x. Yeah, it does. Good. It'd be bad if it didn't, because then you get some really strange behavior, and it would be really hard to debug. And so the reason it doesn't let you do that is because this one is an integer pointer, and this one is an integer, and it considers these to be different data types. And it kind of should, because a pointer, even though I'm not really talking about the size of these things, and I said that it keeps track of it earlier, the size of a pointer should be 8 bytes, and the size of an integer is 4 bytes. So converting that to that would be kind of hard from a systems perspective as well. But yeah, it shouldn't let you. It will require you to make pointers pointers and integers integers. That being said, you can do dumb things in C++. I say dumb, but you can do smart things with it. It's just, I think it's kind of a strange feature. Like this. I can add 4 to the pointer. That's allowed. It'll probably give me a warning or something. Using it's giving it uninitialized. So this would resolve the error. Does it still give me a warning? Nope. So I can do things like add 4 to pointer X, and then that would do something like move this down 4 blocks, that pointer. I guess I should also make this here. This points to that block, because this is the pointer. Yeah, so I could say like pointer plus equals 4, and it would move the pointer down to 10. And that's allowed. I don't know why. I do know why. There's certain reasons why we use it, but it's not something you should really touch very often. Because, again, remember that this just allocates it to some random space, so I have no idea most of the time where this is actually going to end up. That's totally a valid thing you could do in C++, is you can add values to a pointer that you don't even know. Anyways, I digress. So let's talk a little bit about some other things with regards to pointers. So let's just say I wanted to have the pointer point to nothing. Does anybody know how I do that? You might have heard the term before. Yeah, that was quick. You guys got it. So I could set a pointer equal to null. And so in C++, that's entirely capitals. Right, so that's just a way to keep track that I don't want the pointer to point at anything, but I also don't want it to have the random garbage that might be in there originally, because, again, it's just random binary. So setting it to null is a good way to initialize it if you just want to make sure that it's not there. Yeah, that's the way to initialize it. Yep. It's a way to initialize it, and it's also a way, if we're talking about pointers, and you got rid of something that was at the place it was pointing at, it's a good way to signal that you've gotten rid of that stuff as well. So if I was, for some reason, to say I don't need X anymore in this code, I would probably say pointer equals null now. I would do something else, but we'll talk about that in a little bit. Cool. So I think that one's pretty simple. That's just something to bring up. We'll get into the practical applications at some point. Probably when we're talking about dynamic memory allocation. Okay. So let's go back to that code really quick. And I just want to talk about how we use pointers with instances. And yeah, just how we use it with instances. So let me say I have a class, and I'm going to call it person. And they're going to have a name. I'm probably going to need to include some things to make this work. Namespace standard. Cool. So let's say we have a person, they have a name, they have an age. We'll just keep it at that for now. In fact, let's just make this a struct for simplicity's sake. Let's do 2 constructors. So let's say there's a default constructor, and that will just set the name to unknown and the age to 0. And then we have a person, and then let's talk about this a little bit. So similar to that example that we did right at the beginning of class. Let's say I give this the parameter name and the parameter age. How would I set the name and age based off of those parameters? Does everybody remember? Or, yeah, you got it. Right, so this name equals name, and this age equals age. So the this keyword is how I distinguish between those. Cool. So when I call this, it will call this one, right? So maybe when I'm doing my program, I want a person, and just like some of you might do in your programming, I want to reuse this variable because it's maybe kind of annoying to actually, let's turn this back into a class real quick. Let me make these private. Let me give a more practical example. Let's make these private so I can't touch them, and then public. And then on top of that, I will do one called int get age. That will return the age, and then I'll do one called string get name, and all that does is return. Okay, so now as far as we're concerned, what this does is I can set things at the constructor, but I can't set them afterwards, right? I only gave these accessors or getters. I didn't give them mutators. I can't set anything. At least after I'm done with the constructor, that's the only place in which I can set name and age, which is typically a good way to do it in practice. So if I wanted to, let's just say, see out the name of this person dot name, and then we have line. And then for some reason later in my program, I want to create a new person, but I don't want to end up reusing or making a new variable and then consuming more memory than I really need. Then what I would probably do is I'd want to create a new person, but we don't really know how to do that yet, because as far as we're concerned, the only way to call a constructor is with the declaration, that first line, the 26. So there's another way to do that, and it's a new keyword. And if you've used Java and C# before, this is the way you always have to do it. When you declare it like this doesn't actually work. Just makes the space and then doesn't do anything. Is the word new. So I could say this person is equal to a new person. They've changed. And this person is named Jeff, and he's 30. There we go. And it's going to give me an error here. And that's just because of the way new works in C++. So when I call a new person, I'll just put it around here for now. We'll come back to it later. Just put this around so it compiles. You'll see if I run this in the debugger, it will actually go and call that constructor without me creating a new actual variable. So it prints the unknown, that was this line, and then it stops right here. And so when I go to do that, the new keyword calls the constructor, and it calls the one with the name and the age based off of what I gave, because I gave a string and an integer, so it matched that one. So the new keyword allows you to call a constructor and set it equal to a variable. So if I wanted to overwrite a class with a new instance of it, I can use that new keyword to make a new instance, and it will do the constructor and set it equal to it. Is that clear what the new keyword does? It basically constructs a new object. And then I had to put a star in front of it, but we'll get that. So, yeah. So I can also do pointers with people. Or sorry, with classes. I use people in this case. So in this case, I can make a person pointer to a person. And this is actually a little bit better for optimization. And the reason is this is not going to. So if I was to see out person.getName here, yes, it corrected me. We should get garbage. So when you are dealing with a pointer, and again, this is a C++ specific thing, you're going to use an arrow to access a pointer, whereas you use a dot to access a instance. So really I can call all of the same things that the person originally had. I can get age or get name or any functions that I have or variables that are public. I can get the same way that I normally do with a class instance, but I do it with this arrow instead of a dot when it's a pointer. And so it's giving me a warning here, which is good. It should. So if I run this, it should tell me I have an error. Initialize local. Oh wow, it doesn't even let you do that with the compiler. If it actually let me compile, which Sally might, the compiler on Sally might, I would get just random garbage, or I would get a invalid memory thing. It might let me compile it if I did this at least. That won't work, but it will at least compile. Yeah, so you'll see that the pointer for the person is pointing to null, and so if I run it, it should give me a null reference exception. Yeah. Read access violation, write data was a null pointer. And then it throws me into whatever this is. So I can access data that's either null, or if you don't initialize it, which it didn't let me run, I could access data that just doesn't make sense because I don't know it's pointing to a thing yet. So maybe it would make more sense to do something like this. Cool. So now if I print this, it should work. Right, so we have a person named Jeff who is 30, and when I continue, I think it closed the window automatically. But this here would be talking about the person created here. So whenever I do the new keyword, it actually returns a pointer rather than an object. And the reason, I guess I was mentioning for that was that if I just give it the pointer like I had before, it doesn't initialize any data. It doesn't call the constructor at all. So I can effectively say that I want a variable, but I don't have to take the time to actually make it call the constructor, which takes a little bit of time to actually execute, right? And it has to allocate data and set all these things. So if I wanted to just make a variable and not have to worry about that, I can just let it equal a pointer and then set it later with the new keyword that we have there. So maybe I'll put that back. So basically delay actually creating it. And that can be useful because sometimes you might have a program that needs to allocate space sometimes or create a new variable sometimes, and other times it doesn't, depending on the user input. And so you can delay these constructors as long as possible to actually get some more efficiency and wait until the last minute to actually do it. And then, vice versa, maybe if you want a program where you know it's always going to have to load these things and you don't want to have to make the user wait during the run of the program, you might throw these all at the beginning just to make it, get it out of the way first and then run kind of smoothly afterwards. Is that clear so far on when I would use this and what it does? Okay. What else we got? Okay. So maybe we'll do an example first, and then we'll talk about dynamic allocation next time. For second constructor, is setting the instance person name equals the name parameter right because of this? Yes, yeah. This when I put the this keyword for that one, it's talking about that name. But if I don't put this operator in front of it, it's talking about the parameter. It's similar to when I do this, like if I said int x here, and then I did int x here. I said this one was equal to 5, and this one was equal to 7. That would print 5, right? This one overwrites that one. And there's nothing we can really do to get around that. When we're talking about global variables like that. But if I did something, if I did the same sort of thing here, when it says name, this name will overwrite that one. in terms of what I'm allowed to use, not an actual value. It's not going to like destroy it or anything. So if I want to say that I'm talking about the one that belongs to this object, I need to use the this for it. So this one sets this name equal to that name and this age equal to that age. Where did I write that? Okay. So let me see. I wasn't planning on doing a big example, but I might just do one really quick. I did kind of do that game object one, huh? Maybe we'll look at that a little bit longer, because I did already write that, and it might take me a while to think of a better example. We can always talk about dynamic memory allocation next time. Okay, so let's go back to the game object version really quick, because I did modify a few things while we were out of class, and they might not have made sense when I uploaded them. So what I did here in main, so I said earlier I made a player pointer somewhere. Yes, maybe we'll talk about a few things here. I made a player pointer that points to a player. And again, this is good because I don't have to know what the player was at runtime. I don't have to run a constructor. I can always wait until the player is actually instantiated before I set that pointer. So I have a pointer to the player, and I have the player set that pointer in their constructor here. So the player is equal to this, which is a pointer to the current object. And I have that happen when we actually construct the player. So it knows when I'm being made, I will set the static reference to myself. And that way, if an enemy needs to check with the player, they can just check that player reference. That does mean that before the enemy, or like any objects in the game that use that check, can do the check on the player, that the player has to be created. But you can also, for instance, like I did, set that equal to null. So we said earlier that's kind of a way to initialize it. I can set that pointer equal to null and say don't do anything that interacts with the player as long as that pointer is null. And that will stop any sort of errors that are happening, and also probably optimize your code a little bit, because then they won't be executing code so long as the player is null. So it's really just a sentinel, this null here. It's just a way to check that either it's uninitialized or it's been removed or something of that nature. Okay. So yeah, we had that, and then I think I had one other pointer in this program. It should have been over here. So the other thing I had was I made a vector of game object pointers. And so this was good for two reasons. One, the same that we've been saying, which was just the fact that it doesn't need to construct anything at runtime. So even if I made a pointer of, an array of pointers, it wouldn't need to do the constructor on all of the elements of an array like it normally does, which is good because if you have like an array of 100, that's 100 constructors you have to sit through and wait for them to run. And if you have really long constructors, then that might take a little while. So instead we can do it with a pointer, which just says, hey, we want this to point somewhere. We'll talk about, or we'll give it a value later. So right here I've created a vector of game object pointers, and every time I go to create a game object, so we have the player and the enemy, I created a player. In this case I used the constructor the way that we were doing previously, and that's alright because I'm only creating it once. So it shouldn't be that big of a deal. And then I push the address of it, which will get set to the pointer. So I'm saying give this to the game object pointer array, and now it doesn't have to make a copy, which is good because any sort of changes, because I noticed actually a few students had this problem when they were doing the Rocket program. So you had the option to replace that passengers array, or sorry, not the passengers array, but add like an array or a vector of rockets if you didn't want to do obj1, obj2, obj3, obj4. And you might have noticed that if you try to do things to obj1 after pushing it into a vector, any changes that you did on obj1 wouldn't be reflected in the vector, and any changes you did on the vector wouldn't be reflected in the object itself. And the reason that is it makes a copy. But if we do something like this where we do it with a pointer, it will actually be talking about the same object. So if I did, you saw it earlier, I put like player.update here. Update. And then I also pushed the player into the game objects vector. When we do that, this player and the player that's in the vector are talking about the same one because they're using a pointer, which means they're pointing to the same location and they use the same thing. Whereas if I did it the normal way, they would be copies of each other. So anything that happens to one doesn't happen to the other. And that's why we were actually having that bug last class or 2 classes ago, whenever that was. And so I could do the same thing with an enemy. I can give it a pointer. And again, this is where that downcasting or upcasting rather could be useful. Is I can have a pointer to these objects, and then because they inherit from it, I can set it equal to it. So that's at least a practical example of one of how we would use pointers. Is if we don't want to make a copy and we want these to reflect. So anything that happens, I guess, in the grand scheme of things, the reason I would do this in a big program like a game is I can have this here talk about updating all of the objects I've created. So this will update the player since it is an object and I've added it. And then I can also still refer to that same player without talking about a copy by simply using that pointer, in this case the static pointer that I gave in the game object class. So they can all just point to the same thing, refer to the same thing, and all operate on the same object without having to have a global or, you know, anything crazy like that. Does that all make sense? I think that's really all I have to say about programming with pointers. I don't know if I have a super in detail example. I know I'm probably going to talk about ones with like null pointers, but I was going to wait a couple weeks to talk about that because I don't think we need it necessarily right now. Just know that null is a keyword if you want to check for like uninitialized data. Anyways, any questions on that? Otherwise, I'm going to probably talk about a little bit of memory allocation, then we'll do more of it next time. I don't see any questions, but somebody might be typing. But I'll go over to this really quick, anyways. Oh yeah, that printed what we wanted to earlier. Okay. So let's talk about dynamic memory allocation. So this whole time we've been using vectors, and they've been used a little bit like arrays, but they've kind of just been magic. They just always resize to be the correct thing, right? They don't have to be used like an array where I always have to give it a fixed constant size when I start using it. It can be any size, and it just gets bigger as we add things onto it. And we can just, you know, we've been thinking of it maybe like a list where you just tack things onto the end and you could look at the list and all the things that are in it. But obviously it's not magic. They have to have been doing something to make it work. And that something is dynamic memory allocation. So let's just say this is address x, this is x plus 1, this is x plus 2, so on and so forth. So I have some arbitrary address in memory. Now what I might want to do is create an array. And we'll just talk about creating an array first, and then we'll get into how we can actually make it a little bit dynamic. So what I can do is I can create, let's just say I want an array of integers, integer pointer. And so far we've only been making it so that the integer pointer points to one integer. But we could certainly use it to do multiple. So perhaps I could have multiple integers right after another. So the way we've been thinking about arrays is maybe that it's a bunch of data that's kind of in a straight line. And really that's the same thing as it is in reality, in actual memory, is we actually put all of the data right next to each other and then just say how long it is so that we have an idea. So if I wanted to make an array, what I do have the option to do is say something like pointer equals new. Again, we use the new keyword for this integer, and then I give the size of it 10. Actually, let's say this is 6. So what this will do is it will allocate a pointer. So let's just say that's here. Pointer. And now I can actually access data. So this will say allocate 6 integers for me. And we can then treat them like an array. So what this will do is it will make this pointer go here, and it will say I'm going to use these 6 blocks. So this whole thing here, that's mine now. And so I can use that exactly as I would use an array. So if I did cout pointer sub 0, this would print 4. And if I did something like cout pointer 1, that would print 5. So I can basically make an array and tell it to just allocate that many integers in a row and then have a pointer to the start of them. And then when I do this, it will just say, it will basically hop over these and find what block it's in. So as an exercise, what do you think would be printed if I did cout pointer sub 4? What do you think that would print? Yeah, everybody seems to be getting it, right? 9. So again, this will look at this being 0, 1, 2, 3, 4, and 5. And so it will say, the 4th position, that's 9. So really it works the same way as a normal array is, or does, but it just, you have a little bit more control over it. So far this is just the same as an array, and it might seem kind of arbitrary. Why would I actually do this? Well, yeah, we mentioned vectors earlier. So those are able to dynamically resize themselves. So what if I gained more information? My program now determines I need 3 more integers from the person. Then I might want this to not be pointing to 6 anymore, but instead something like, I don't know, 9, right? So maybe it wants 9 objects. So I need to do 2 things potentially. You can maybe optimize this, but it's a lot of work. So for the sake of the time being, let's just say we want to create a new thing. I'm going to leave a bit of a space here. I would just say pointer equals new int 9. And then what that will do is it will actually, it's not going to just expand and make this 3 longer. It's going to go out into memory, and it's going to find a new place that's 9 long. And it's going to use that instead. Now the problem with that is that all this does is it allocates space. So these things I assume were set somewhere else. All this does is set things. So if I said pointer equals new int 6 and pointer equals new int 9, I have more space to work with, but not all of these values are going to get copied because it doesn't necessarily point to the same place. So consider, again, the way the new keyword worked is it created a new constructor. In this case, it's a constructor for an array. And when I do that, it's going to allocate new space, which means this pointer gets set to a new number, whatever the pointer is for the actual place in memory that this array has been made. So even though I did this, it's maybe not actually useful because I haven't copied anything. So let's try to write that up in code really quick, and then we'll just talk about the delete keyword, I suppose, to end it off. So let's say I make an integer pointer called array, and then I set it equal to a new integer array. Okay, and then I set r0 equals 0, r1 equals 2, r3 equals 5, r4, I skipped counting, 2, 3 equals 7. Okay. So if I was to see out r1, it should print 2 like we said earlier, and then I might do something here where I say, oh, I want more space now, and make this a 6 integer array. And now you'll see when I print 1 that it shouldn't be the same thing. So if I run this really quick, we should get r sub 1, which is 2, and then we should get random garbage. Or it'll give me a read access error. We'll find out. Or I still have a breakpoint. Oh, yeah, it finished running. There it goes. So it printed Jeff, and then it printed 2, and then it printed, I don't know, negative 84 trillion or some ridiculous number. So this is uninitialized data. So what we might want to do is then, we know when we create this new keyword is that it's creating a new pointer. So when we go to allocate more space, we want to make a copy. So I would do something like int temp, and then I would let temp equal the new integer instead. So I'll allocate the space using a temporary value, and then I'll just copy them over. I less than r dot length. That should be a field, right? I don't know why it's not showing up. I plus plus. I might have to include some sort of class. Mustn't have class type. Oh well. I'll figure out what thing that's in. We'll just say 4 for now, because we know that's 4, but there should be a way to tell. Maybe it's size and I'm just forgetting. R dot size. No, still not. Oh well. Let's just say 4 for now. Not good practice, but I'll figure out what it actually is. And then I can copy each of those over. Equals r sub I. And now I've copied these 4 values over to the first 4 positions of this one, and then I have the 2 extra from 6. Right? Does that make sense so far? The fact that when I create a new integer or a new pointer, it will allocate the space, but it's not going to copy things over, so we kind of have to do that manually. Now, last thing, and then we'll maybe talk about assignment 3 for a few minutes, is... Oh yeah, actually, maybe I want to keep using the array. So I would do something like that. So now this array points to the new space that I've allocated and copied things over into. So basically, I've created an array and I made it too longer, and I had to do that by making new space and then copying everything, which is a little inefficient, but it's also very handy because that means that I don't have to make an array a fixed size. And I don't necessarily waste space. I waste a little bit of time, but I don't waste as much space. Yeah, so the problem with this so far, which we'll just briefly do, is what's happening is we have pointer pointing here. We allocate this space, so I created that variable called temp. We copied all this stuff over, right? So that went there, that went there, that went into that one. And then I move pointer to there, and now it's not pointing to that anymore. So what happens to all this space that used to be there? What happens to all that data? Or does anything happen to it? Still there. Yeah, it's still there. That's a bad thing because now the system doesn't know that we're done using it, which means it's what we call a memory leak. Memory leak. We have memory that is still allocated but not being used, and we have no way to get back to it because we got rid of the pointer. So the way we get around that is by using the word delete. This is another C++ and C specific thing, is we would delete the array. And actually, if you're talking about an array, you want to put that. You want to put brackets around it to specify that you're deleting an array. So I could delete an individual like integer or class type as well using this keyword. If I put the brackets in front of it, it knows that it's an array. So it will deallocate all of that space. And so what that does is it will simply, before we moved this pointer from pointing to there, let's go back really quick. So just notice I deleted it before I copied the pointer, right? So I deallocate all of this pointer at the array space, and then I point it over here. And delete doesn't actually delete them or clear them, but rather simply says this space is now free for everybody to use again. So the compiler or the system, the operating system, now knows it's allowed to use that memory again for future variables. And again, similar to what we were saying earlier, with if you declare something but don't initialize it, there's just going to be random garbage there. This is what causes the random garbage. Is if I just delete the pointer, it's just going to leave it there but say you can use it again. So it's very important when we're working with C++ and some other languages like Python that we use this delete keyword, because it will actually allow that memory to be used again. And you'll notice that if you don't do this and you're running something big like a game, then you'll run out of memory and the program will potentially freeze or crash. And that's because of the memory leak. Is that all clear as far as what that stuff does? We'll maybe do a little bit more of a detailed example next time at the beginning. Okay. I'll wait for questions, but I'll also open up assignment 3 just to talk about it for a moment. And I know class ends in like 1 or 2 minutes. So if you have to go early, by all means go, and then I'll just talk about it. It'll be in the recording, so if you need to look at it later, there's that too. Okay. So, I know we don't have a whole lot of time, but we'll talk about this a little bit. What you're going to have to do in assignment 3, and I'll pull open the actual skeleton code, is you have a player class. So you have player class.h here, and it has a player base class. So this just describes the generic player. And a generic player has something like a weapon, similar to what I did with the game objects in our example. He gave a static count, which just keeps track of how many players are in the game right now. And then the player has a name and some stats like strength, skill, HP, stuff like that. And so we have 3 derived classes: a red player, a blue player, and a green player. And we want them to all have different names, different types, and then different stats with these ones. So you'll notice that there is a constructor here that takes a character, which is this one, the string, which is the name, and then 2 integers, which I think are strength and skill, but we can always double check the rubric. And those differ from class to class. So what you're going to want to do is you're going to want to, in this constructor, similar to what we did earlier, you're going to want to call the player class constructor in this fashion with that colon, and then specify the specific things. So for some, if I knew what these were, I would say maybe the red class, I want that to be character R, and call them red player, and give them 20 and 10 for their strength and skill. So the idea is that you'll do that for all of these. Have the base class constructor call the player constructor here from the base class. Or sorry, did I say base earlier? I meant derived. the derived class called the base class constructor, this one right here, using this, and you would fill that in with the information that makes sense for it. So the idea is that each the red, blue, and green differ, and we can override the constructor to call with the parameters that we want. And then the other thing that you'll have to implement for each of those is a do damage, and I think there's a take damage, but taking damage is the same across all classes. Do damage is a little bit different. So there's a almost like a weapon triangle kind of thing going on. Like red does more damage to blue, does more damage to green, something like that he has here. So red does twice to green, green does twice to blue, and blue does twice to red. So yeah, we have a triangle with weaknesses, and then you just kind of do damage. So they all do damage in different ways, hence we have a do damage override. So you're going to be given the player that you want to do damage to, and then you could determine the amount of damage that you actually want to do based off of that weapon triangle. So for instance, this red one here, red does twice damage to green. So if I was to check this and figure out that the, let's just say, character player type was G, let's just say for green, then I would do 2 times damage. But if I figured out it was red, I would do half damage, and if I figured out it was B for blue, I would do normal damage. Whatever that number actually is, I'm not entirely sure. And so what you would need to do is you would need to make that other player take damage, right? So what you'll want to do is take this player that you're doing damage to, make them take damage, and figure out what the number is based off of that chart. And then I think the last thing I'll mention, unless we have questions, is that, so there's some other functions I'm not mentioning, but those are kind of the main ones, is that there's a scripted battle already for you. So it creates like a red player, a blue player, a green player, equips all their items, and then has them fight, and it should be the same every single time. Does that all make sense? Anybody have any questions, I guess, before we call it a day? So main is fully written? Yeah, it should be. It should just be a scripted battle. So you just need to do the constructor, the do damage, the take damage, and then the equip weapon, and there's descriptions of all of them. I think the main thing that I saw questions in the Discord about was these two, just because I don't think I explicitly mentioned them. I kind of just waved my hands and said, object-oriented programming is cool, and that was about it. Any other questions? Oh yeah, I have a question about the do damage functions. In the do damage function, it says to use the weapon class to determine how much damage will be dealt. Call calculate damage. Yes. Does that have a member called calculate damage? That does sound like it makes sense to me. Damage dealt by weapon? Yeah, I think so. This returns an integer, so I think that would return the damage, and then you just either multiply it by 2 or a half, depending on that weakness cycle. Yeah, that sounds like it makes sense to me. How do we use header files? All you have to do is include it. So if I go to main, you'll see that it includes playerClass.h, and playerClass.h includes weapon class. So whenever you use that include, it basically just takes all the code and puts it at the top in place of that include. So by doing this, this will include player class, which then includes weapon. So it will just basically copy and paste all of the code at the top of the file. So when you compile it, and I think he has a note on it in the rubric, you just want to compile main.cpp. So you don't compile header files, they're just there for extra information. And you can write code in them. In fact, I think he suggests you to. That's not C++ standard, although I would probably do it too, honestly. It's not accepted that you're supposed to do that, but I would write it there. You usually write all the code in a main, and then the header is just there for declarations. And if we wanted to compile multiple files, you would just compile all the CPP in one line. So you just put like g++ main.cpp, second.cpp, third.cpp, stuff like that. Which the next assignment is going to force you to do, I think. Any final questions? I'm probably going to head off in a minute or two here, just because I have class after this. Whenever I try to run the debugger, it says unable to start. Is it giving you a compiler error, or is it giving you something with the executable? The executable. So from my experience, that could be one of two things. One, it's either giving you a super unhelpful message, and you do actually have a problem with your code, like a compiler error, and it's just not actually telling you the compiler error and just saying that, I can't run this, which is really hard to find. That's typically pretty difficult to work with. Or the other common problem I see with that from experience is that it tried to optimize the way it compiled your solution, and it recompiled things a little bit. It compiled some things, but not all the other ones, and it has some code that just doesn't work together, and it doesn't know what to do with it. In which case, you can either go to... I should have kept Visual Studio open. I don't know why I closed it. That wasn't a very smart move. You can go to Project and then Clean Solution. Sometimes that fixes it. In my case, at least when I was doing app development, it usually doesn't. So let me reopen it really quick. Yeah, and Sally will probably give you more helpful errors for that too. But I would say either go to Project and then, or actually, sorry, it's Build. Build and then clean that. And then there's also, if you go to the actual directory itself that your file is in, what usually helps me, I guess it's a little bit different with the way it compiles C++, is to delete this debug folder. But if you're doing other languages, there will be a binaries folder and an objects folder where it stores binaries and object files. I usually delete those, and that fixes it sometimes. So I would try deleting that if it doesn't work, and then try rerunning it. If not, it's probably a issue with your actual code, and it's just giving you a very unhelpful message, in which case it's kind of hard to figure out. And then, yeah, I would say just run it using a different compiler that's not Visual Studio to try and figure it out, if you have the ability to. Obviously, with like big programs like I was talking about with that app I developed, that's not realistic. But then you just go to Stack Overflow and hope for the best. Hope somebody else figured it out for you. Alright, well,